In this lesson 19, we're going to look at evidence, angles, and proof, and we're going to make some convincing explanations. So take some time to look at this picture and see if you can mentally evaluate the missing angles. So missing angles being this one, also this one. So hopefully you remember that a straight line is 180 degrees. So we've got that one, which would also be this full top angle. And so this missing one right here would be 130 degrees. If we do 180 minus the 50 that's already there, we would get 130 for that. So we're going to look at making some informal conjectures about angles. So on this screen, go ahead and pause the video and write down some things that you notice and wonder about these three pictures, and then come back and I'll discuss some things that we noticed and wondered in class. So some things that people were noticing is they saw dotted lines, dotted and solid lines. They saw two dotted in every picture, two dotted lines. Wondered about what are the dotted lines. Some people noticed that the dotted lines look about the same size. Which other people wondered, are they the same size? Are the dotted lines, whoops. So the same angle each time. People noticed that the dotted lines look like turned right angles, which then people also wondered, do the dotted lines make right angles? Okay, so a couple of different things, and again, you could have noticed other things and wondered other things. This is just a few of the notice and wonders that we talked about. So then let's take a look. So in here we have a figure where ray R, so this ray means it extends forever in one direction. It meets line L by, and then the dotted lines are actually angle bisectors. Okay, so the dotted lines are angle bisectors. Remember, split the angles into two equal pieces. And so Diego noticed the angle formed between the angle bisectors is a right angle. So he's suggesting that this angle here created a right angle no matter what the angle, no matter what these two bigger angles are. Okay, so no matter how big this is or how big this is, he thinks this will always be a right angle. So when we look back to here, okay, no matter what the size where this ray R was, didn't matter. Those angle bisectors always created a 90-degree angle is his hypothesis or conjecture. So it's difficult to tell specifically which angles Diego is talking about in the conjecture. So can we label the diagram to make it look a little bit nicer? So if we go like this, we've got the angle bisector. Angle bisector means that the two angles created are the same. So let's just give them the same letter degree because we don't know how big they are. So let's just put A. For this one, let's just put B. So what Diego is actually hypothesizing here is that A plus B is a right angle or equal to 90 degrees. Okay, so he thinks that A plus B is equal to 90. Okay, is he right or is he wrong? So do you think his conjecture is true or is it false? Put some language to why you feel that way. All right, so let's take a look at some ways that people talked about this. Okay, so you could try to do some type of justification of rotating ACE over to this one. Okay, so this angle could rotate into the other and this one up, thinking about 180 degrees. So it was the straight line is 180, so if we just rotate those up, they cover each other. Maybe that makes you feel like it's 90. Okay, to get this angle in here. If we wanted to actually write a convincing argument or do a proof for this, okay, and actually prove it, so we could take a look at this. We looked at in the warm-up that a straight line this much is 180 degrees. So if we take a look, we actually have all four of those angles creating that straight line. And we know that a straight line is equal to 180 degrees. So we could actually go in here and say that we know A plus B totals that straight line. So those are all of the angle measures of this straight line. So we could add them all together and know that it equals 180. So then if we start to manipulate this by putting the A and the A together, that's two A's, and put the B's together, that's two B's, equals 180. Then we could see that both of these have a 2, so we could factor the 2 out. So when we factor the 2 out, we're left with A plus B equals 180. Then we could divide both sides by 2 and know that 2 divided by 2 is 1. So then we get down to A plus B equals 90, which is what Diego's conjecture was. And here we just proved it without any numbers for these angles. So for instance, we didn't have like 60, 60, 30, 30. Okay, we just had A and B. So now anytime, no matter what this is, it will equal 90 is what we just showed. So let's go back to this warm-up problem quick and take a look. So if we drew in the angle bisector here, so if I drew in the angle bisector here, that would make these each 25. And if I drew the angle bisector in here and split the 130 in half, that would be 65 for each of these. And 65 plus 25 is equal to 90. So it worked in that one. We'll work in all of them as long as you have your angles correctly labeled. All right, then let's take a look at another pair of angles and make some conjectures on this one. So here we have what are called vertical angles, and vertical angles are just any time two lines intersect, you get two pairs of vertical angles. So we've got these two lines are intersecting, so we've got vertical angles, which are just the ones across from each other. Okay, so if I just labeled this, we could go back to doing A. So if I labeled this A, this B, this C, and this D, then A and C are considered vertical. Okay, so those are vertical angles, and B and D are vertical angles. Okay, so the ones directly across from each other. So see if you notice a relationship that you think is happening there. And then see if you can explain how you know it's true for all possible pairs of angles. And you could label this picture differently depending on how you're planning to prove this. So I'm just going to put a bigger screen here to talk about this. So some different ways you could have done this, like maybe you labeled the angles on here with letters so that you could talk about rotations or reflections and some transformations here. So maybe you notice that these two angles looked like they were reflections of each other. So you could reflect it. You could think about reflecting it over this line. And if you reflected it, C would go down to D, A would go down to E. And let me actually draw this on here and see if I can reflect it on the video. So I don't know if I'll be able to reflect it since it's not vertical. Yeah, it's not going to go exactly since this isn't a horizontal line here. But if you were to reflect it over, okay, then you would get this exact same angle. So I'm not going to be able to reflect it, but I'll rotate it over here to show you that they're exactly the same. Okay, so thinking about reflecting A down to E and C down to D, or even just translating A down to E and then doing that reflection. You could also think about rotating. So maybe you talked about rotating A over to D and as you around B, so leaving B the same. So sticking B, but then rotating, okay, you know, BC all the way over to here, which would also rotate AB all the way over to here and seeing that angle, this angle landing on that one. So maybe you talked about rotations. So it could have been rotations or reflections there as part of your justification. And then if you wanted to practice actually proving that this is true, maybe some of you talked about how this angle here plus this angle here is 180. And this angle plus this angle is equal to 180. And maybe I should use different letters since I've got A, B, and C. Let's do W and X here. And then Y and Z. So maybe you talked about how you know W plus X equals 180. And you said X plus Y is also equal to 180. So then you felt like W must be the same as Y because that W or Y plus X is always 180. So X is always the same. So then Y and W must be the same. So maybe in your head you felt like that made sense. So here's the algebra that would be behind that. Okay, so let's take these two equations. I'm going to solve this one on the left here for X. So I'm going to subtract W from both sides. So I get X equals 180 minus W. So then I'm going to plug this in for X right here. I'm going to substitute it in. So instead of X, I know that X is equal to 180 minus W. Plus Y is equal to 180. So now I'm going to subtract 180 from both sides. So I get negative W plus Y is equal to 0. So then I'll add W to both sides. And that helped me figure out that Y is actually equal to W. So Y and W are exactly the same. So this angle is always equal to this angle from that algebra. And then similarly, you could set one up to solve for X and Z. Okay, so you just need to get whichever one you're trying to solve for. So we solved for X that time. So we wanted to prove that W and Y. So if we're trying to prove that X and Z are the same, we're going to get those into both equations. So I'm going to do Z plus W equals 180, and then X plus W equals 180. So that we have both the Z and the X, one in each equation. Then you could do a very similar process here to show that Z and X are equal. So that would be the mathematical proof. Okay, so you maybe talked about rigid transformations, maybe talked about straight angles adding to 180. So what's the difference between an angle and an angle measure? So angle is the picture, okay, and using transformations, rigid motions, that it's the same shape and size, but you don't actually know the measurement. Where here you would use a protractor and actually come up with the size of the angle in degrees. So you would measure this. So this is like an actual number, 23 degrees, 90 degrees, 42 degrees, 128 degrees. You've actually measured the rotation here, okay, versus just the same shape and same size on a picture without angle measures there. All right, so looking at what we figured out today, we figured out vertical angle theorem, okay, and that is that vertical angles are always congruent to each other or equal. So whenever two lines intersect, okay, whenever you see two straight lines intersect, again, doesn't matter what angle they intersect at, they're going to create a set of vertical angles. And those vertical angles are always going to be congruent to each other. So the ones across from each other are always going to be congruent to each other. So these two stars are always equal no matter what the angle is here that these two lines cross at. Okay, so across from each other, always equal for vertical angles. All right, so we looked at a couple different things and we came up with some ideas. And then we came up with reasons or justifications as to why those observations or things that we saw were true. We looked at having convincing arguments and ways that we can prove that it's true or false. Okay, and looked at actually proving the relationship of vertical angles. Okay, so we did do that algebra version. Okay, and you can see it in here where they talk about that means that x plus y equals 180. So we did a similar thing. And y plus w equals 180 and solved for that to prove that they were equal to one another, which you are going to have a chance to do in your cool down. Okay, so hopefully you can label and make conjectures from diagrams to make some convincing arguments and then prove that vertical angles are congruent. This is with the letters like I did and adding them to 180. And you do have a chance to do that on this cool down. So you're trying to prove that A equals C. So set up an equation that uses A and C. So your starting point would be to say that you know that C plus B equals 180. And then A plus B equals 180. So make sure, and you could have done it with D as well. So you could do C plus D equals 180. In which case then you need to reuse D. So A plus D equals 180. So make sure you have both C and A in an equation, and the other letter that you use is the same. Okay, so here I have C and I have D, or sorry, C and A, and then I used it with D. Where here I had C and A, but I used it with B. So then solve for B. So subtract C to both sides, then plug it in and solve. Then you also have your lesson practice problems for 19 on page 138 to 141.